So I'm back with a new problem, which is the second part of the example that we just started with. It's going to be kind of similar. It's asking us to prove that for every integer greater than or equal to 0, 8n minus 1 is divisible by 7. 8 to the power of n minus 1 is divisible by 7. So I'm starting with proof by induction. Let n be an integer and greater than or equal to 0, and the base case is 0. So when the base case is 0, I'm supposed to be testing if 8 to the power of 0 minus 1 can be divided by 7. Well, let's find out. 8 to the power of 0 is 1, and 1 minus 1 is 0, but that's the same thing as, 7 times something. Well, what thing? Actually, 0. So, turns out that the theorem is actually, in fact, true. So far, it's looking good for this theorem, and we can continue on to the inductive hypothesis. Great, so in the inductive hypothesis, we're going to suppose that 7 divides 8k minus 1 for some random k, and we would like to show that 7 divides the next integer. So again, I'm going to start by considering the quantity 8 to the power of k plus 1 minus 1, and I'm going to try to break it down as much as possible. So I'm going to start by breaking the k plus 1 apart by doing k and doing 1 and putting the 8 on the with each one of those powers, and then take the 8 itself and breaking it apart. And this time I'm going to break it apart into a 7 and a 1 because I'm trying to prove that the quantity is divisible by 7, so it's convenient to kind of like make the 7 show up. And again, distribute the 8 with the 7, we get 8k times 7. Distribute again, we get 8k plus 1, and then, times 1 is going to be just times 1. Let's make it visible. And then there's the minus 1 at the very end. So far, that's great, but we know that this 8k minus 1 is divisible because of the inductive hypothesis by 7. So this is divisible by 7 because of the inductive hypothesis. So if that's true, then I can kind of rewrite it. Well, I can say since 8k minus 1 is divisible by 7, then there must exist some integer, let's call it m, such that 8 to the power of k minus 1 equals to 7 times the integer m. This is by definition of divisibility. But now let's just go ahead and punch that in back to the original expression and see what happens. So if I punch it back into the original expression, I'm going to end up with something like this: 8 to the k plus 1 minus 1, which was equal to all of these equals. Well, when you rewrite the whole expression, it's going to be what? It's going to be 8 to the power of k times 7 plus the 7m. So I'm taking pretty much this and converting it with the new notation. So at this point, I'm seeing a first factor and a second factor that share a 7. So let me factor the 7 out, and I'm going to end up with 8k plus m, which is, again, basically an integer. And 7 times an integer means that 7 divides the original quantity. So that's what we're going to finish with. We're going to say, so 7 divides the 8k plus 1 minus 1 by definition of the word divisibility. And this is what we wanted, so our proof is basically finished. QED. See you on the next video.